Hello, today we're going to go through the calcium in water demonstration and take a look at the equation that we have in front of us. We are going to take some calcium. The S next to that symbol represents that calcium is a solid. We are going to mix it then with water, and you can see the L in parentheses means that water will be in the liquid form. What we end up with then will be calcium hydroxide. This AQ represents aqueous, which means it's going to be a solid that is within a liquid, and we're going to end up with hydrogen gas. And again, that G in parentheses represents that it is in gas form. The first thing then that we want to do is identify parts of our equation. The atoms and the compounds that we start with, we call these our reactants. Whatever we end up with, we call these our products. Now we want to analyze our equation as well. Is this a balanced equation? Remember that the law of conservation of mass says that matter cannot be created or destroyed. It's just going to change forms. Whatever atoms we start with on our reactant side, we're going to end with in our product side. However, they are going to be arranged in a different way. So let's take a look here as to how many atoms we have on our reactant side. So we're going to use our skill of counting atoms. First, starting with calcium with the symbol Ca. There's no subscript coefficient, so that means there is one calcium atom on our reactant side. If we take a look at hydrogen with the symbol of a capital H, we notice that it has a subscript of 2, that's the small number to the right of the symbol, but there is also a coefficient, this large number 2, out in front. When we distribute the coefficient, we multiply it against the subscript of 2. That means hydrogen atoms count up to 4 on the reactant side. That coefficient 2 also gets distributed to the oxygen atom. We are understanding that it has a subscript of 1. We multiply those, so we count our oxygen atoms at 2. Let's take a look at our product side. Again, calcium has 1 atom. There's no subscript, there is no coefficient. Now, O and H are in parentheses, so I'm going to distribute the subscript 2 that's outside of those parentheses to everything inside. So our oxygen atoms, we have 2, and our hydrogen atoms, we have 2. But we also have to not forget about the hydrogen gas that's over here in our products. It has a subscript of 2, so we're going to add on 2 more for a total of 4. Let's compare the numbers then with our reactants. We can see that those are equal, so this is a balanced equation. When we look at calcium, we can get some physical properties of calcium. Now, many of us think of calcium as white because it's in milk, it's in our bones. However, calcium is gray. It is a solid and it is a metal. Water, some physical properties of water. It is a liquid. It's clear and odorless. In a moment, I'm going to show you the reaction, and from there, we're going to take a look at the properties of the products. Let's take a look at the reaction. Right there, I added in something called phenolphthalein. Phenolphthalein is an indicator. If there is a change in color in that water, that means whatever is in the water is basic. When we compare acids and bases, it would be more of a base. So if that water turns a color, it's not necessarily due to the 5 signs of a chemical change. However, it is telling us that there is something new in the water. Now I'm adding in the calcium to the water. We're going to watch and see what happens. The reaction's taking place. There's a gas being released. There are bubbles. The water turned pink. Oh, it's hot. We can also see, we're going to have a close-up in just a moment, where we can see, no close-up, let's see if I can make it here. There is a white solid that's in the bottom. So we see the signs that there's been a chemical change. We have bubbles, and which means that a gas has been formed. And we have a precipitate, that solid that forms in the bottom, and it falls to the bottom of the test tube. This also had a change in temperature. It got very hot. So now we are going to put this aside and see if we can come up with the physical properties then of our products. We are ending up with calcium hydroxide, which is the white solid that falls into the bottom of the test tube. And it is basic, meaning that when that water turned pink, that was an indicator that something was not acidic, but basic. We also had hydrogen gas. I'm going to just scoot this over here. The hydrogen gas obviously is in gas form, and it is colorless and odorless. The reason that you saw it white was actually water vapor. It was so hot that steam actually forms. So the white gas that you saw there was just water vapor. So that's our calcium and water exothermic reaction, and we learned a lot about chemical equations, counting atoms, physical properties as well.